Okay, so we've got yet another application of a quadratic. It says the position of an object moving in a straight line is given by s equals 2t squared minus 3t, where s is in meters and t is the time in seconds the object has been in motion. The question, how long, and it says to the nearest tenth, will it take the object to move 9 meters? Okay, so we know that the distance we're trying to go is 9 meters. So what they're telling us in essence is that s, this distance, all right, the position is 9 meters. M for meters, that's an S. All right, so S equals the distance and T equals the time. Okay, so we are trying to go 9 meters, and we're going to set that equal to our equation, 2t squared minus 3t. Okay, yet again, another quadratic that we can probably factor. So let's get this equal to 0, and then we'll be on our way. So I'm going to make this really quick. 2t squared minus 3t minus 9 equals 0. Okay, so I'm going to tell you right off the bat, this right here is completely factorable, but you can go about solving this quadratic in any way that you'd like. Okay, but let me go ahead and maybe impress you a little bit with my modified AC method. And I'll put a link in the description at the bottom so you can see how I solve these modified AC problems. So we do 2 times negative 9, we get negative 18. Okay, there's my negative 18. And let me write down the factors real quick. I've got 1 and 18, I've got 2 and 9, and then I've got 3 and 6. So I want the factors of negative 18. There's where I get the AC part, A times C. I want the factors of negative 18 with a difference of negative 3. Well, the only set of numbers here that have a difference of 3 period are the 3 and the 6. So that means if I need a negative 3, it should have to be positive 3 and negative 6. Okay, so here comes the fun part. We have plus 3 and we have minus 6. So there's the plus 3 and the minus 6. And then I say very loosely divide by AX. In this case, we're going to divide by AT. Well, what was A? A was 2. 2T. 2T. Okay? Then, what we do is we reduce the fractions that result. Now, some of you may be wondering, well, why would you want to do this? We've got fractions. This is actually really easy, and they're really elementary fractions to reduce. So what's 3 over 2? Can't reduce it, just leave it. What about negative 6 over 2? We can reduce it. What do we get? We get negative 3 over t. Well, there's a very famous song, and there's maybe, I guess, 2 different songs. One's, a country song, the other one's a rap song. But in both songs, in any case, the lines are uttered bottoms up. So that's exactly what we're going to do, bottoms up. The bottom comes up, the bottom comes up, and when we get bottoms up, we get 2t plus 3 and t minus 3. Probably a really cool trick that you've never seen before, but this is really interesting. So now, all we have to do are solve by using the zero factor property, these 2 very elementary equations. There's a 1-step equation, that's a 2-step equation, that will be done in just a jiffy. So let's see. 2t plus 3 equals 0, and t minus 3 equals 0. Let's start off with the easy one. In this case, t equals 3. All right. And then let's do the next one. 2t equal negative 3. I just move that to the other side. Divide by 2. T equal negative 3 halves. But we're looking for how long will it take in terms of time. Can we have a negative time component? Well, maybe in some other physics application, all right, but not here. We definitely lose time, but time is not negative in this scenario. So this could not be an answer. So the answer to the question, how long will it take it to move 9 meters? And the answer is 3 seconds. So the time is measured in seconds. and it'll take it exactly 3 seconds to move a distance of 9